Hello, everyone, and thanks, Dan, for introduction, and thanks everyone for listening my talk. And Professor Dr. Chang provide valuable information about the conventional impact, environmental impact of conventional energy system. Now, in this presentation, I will discuss renewable energy systems, solar, wind, and geothermal, their importance and potential environmental impact. Before going into more details, let's have a look what is the potential of renewable energy system. Based on the figure in the right side, it shows that renewable energy source have the potential to provide 3,078 times the current global energy need, of which solar energy is providing the highest amount, 2,800 50 times, whereas wind energy 200 times and geothermal energy 5 times. If we look at from this times to the number digit, it shows that the solar energy can produce 6.5 million gigawatt of electricity, whereas wind can produce 1.7 million gigawatt of energy. As of production, as of 2020, total 90% of the global electricity is coming from the different renewables sources, of which the solar, wind, and geothermal are contributing to around 10% of this energy. So from this, and now it comes to why renewable energy is important. If we look at and compare the greenhouse gas emission between renewable energy and conventional energy system, then we can see that in the left side, this is the greenhouse gas, carbon dioxide, and then compare with the renewable energy and conventional energy. The solar, wind, and geothermal has a very less amount of carbon dioxide compared to conventional energy systems such as coal, oil, and gas. Similarly, sulfur dioxide, nitrous oxide, this also way less than the or near zero for the renewable energy compared to the conventional energy system. Therefore, it comes to move from carbon intensive energy to renewable energy system can help us to mitigate the climate change that we are facing nowadays with the different extreme environmental situation, and safeguard the energy security for the future, as we see that it's an enormous amount of energies out there, and increase the sustainability of the human activities. For example, in USA, if solar energy contributes 10% of the national demand, then reduction of carbon emission would be 6.5% to 18.8%. So this and now it comes to see that in terms of world prospect, what is the status of Canada in renewable energy? Canada is 9th in solar energy production and 8th in wind energy production, and we have a very less amount of geothermal that's mostly used for the heating purpose. And in the right figure showing that the change of or progress of solar and wind energy system from 2005 to 2017. And first geothermal plant is about to establish in Saskatchewan. That is will power around 5,000 homes, and it can offset 27,000 ton carbon dioxide per year. So from the Canadian perspective, let's have a look to the Alberta. What is the status of Alberta in terms of renewable energy? Solar energy in Alberta currently have 0.1 gigawatt, and that can offset almost 50,000 carbon dioxide equivalents. And by 2025, this solar energy production will be 1.8 gigawatt. Wind energy currently 1.8 gigawatt, or 9% of the total energy supply in Alberta, and third in Canada, and 6.5 gigawatt would be in by 2025. Geothermal energy, we are in the very beginning stage, and 3 plant is approved with approximately 36 megawatt. So this is the overall picture of the geothermal, renewable energy system. And now it comes to that everybody thinks the renewable energy is uh, uh, clean and it doesn't have any impact. So the question is, are solar, wind, geothermal energy as clean as widely believed? Let's have a look. Before going into detail, just give in brief how the solar panel works. In this figure, if you look at the sun, we get the sunlight, and then the solar panel use the sunlight and produce electricity and transfer to the home inverter and then use the electricity. And if the house producing more electricity, then some of the electricity can transfer to the grid, and less electricity then comes from grid to the house. And this is the way solar energy is working. So now what is the possible environmental impact we are getting from the solar energy system? Due to the construction of the solar farm, so major cause is soil compaction. So using the equipments and all this can causes the soil compaction, and cleaning the vegetation of the topsoil. Because of the construction, then topsoil erosion occurred, and due to topsoil erosion, increase the sedimentation and turbidity in the local stream. Then water. The dust is the dust deposition on the solar panel decrease the amount of solar radiation absorption. Therefore, it needs to clean. So 860 liter per megawatt hour is required to clean the mirror and panel of panels dust, and up to 90% of the water used by the solar this energy system are using for dust cleaning. Then comes to the emission. For generally in operation stage, solar panel is not emitting any emission, but during construction or manufacturing, panel manufacturing, it produce 14 to 18 gram per kilowatt hour carbon dioxide and 0.1 gram per gigawatt hour mercury it can emit, as well as there's some emission during the construction and the transportation stage. Then environmental impact. So obviously any kind of disturbance on the land, its vegetation loss will occur. And the most important factor for the solar energy is the wildlife mortality. From the different study in USA, it shows that 37 to 138,000 birds killed by the solar panel solar energy system per year. And as well as habitat loss and fragmentation because of the big area required to establish the farm. So it loses the habitat, especially for endangered species if there is something, or create a landscape fragmentation. As well as when the farm is established, there need to be make a boundary, and therefore it creates a barrier for the wildlife movement. The footprint. Generally, a solar farm requires a bit higher footprint than the any other energy system, but over the long term period, if we consider the life cycle around 25 to 30 years, it requires less amount of footprint, and it's estimated that 8.69 to 56.3 meter square per kilowatt. As well as it conflict with other land use system like agricultural land, forest land, or other land where it established. So always there is some conflict about the with the land. Then hazardous waste. So solar panel generally to prepare solar panel required the chemical compound cadmium, selenium, and lead. So cadmium used as a semiconductor to convert the solar energy to electrical energy, and it requires 5 grams of cadmium per meter square of solar panel manufacturer. And this cadmium is highly toxic, and potential exposure to cadmium dust and vapor can be a carcinogenic. Then comes to the wind energy system. So again, similarly, just to give a brief how the wind energy works. So wind blow past turbine and rotates the blade. The kinetic energy is transformed into the mechanical energy, and a gearbox spin the generator to produce electricity, and then this electricity go to transformer and to the grid. So this is the way is wind energy work in a brief. So if we consider the environmental impact for this wind energy, the most important one is the visual issue. That's the change the natural landscape view. When you see the long big tower, wind tower on the landscape, some people is not like it, but it depends on the perception of the different people. Some people like, some people does not. So it's depends on the people perception, as well as NIMBY syndrome, that is called not in my backyard syndrome. And in that case, some people don't like to see the wind turbine in their backyard or near house. And another impact is shadow flickering. When the turbine blade is rotating, then sunlight reflecting on the blade, and it can causes this shadow flickering, and that's the very annoying during the driving or is far from the house, or shadow flickering. Then vegetation and wildlife. So for vegetation, habitat loss, wildlife movement, that's the similar like I explained to in a solar energy system. So all disturbance have some form of impact on habitat loss and wildlife movement and various. As similarly in wildlife mortality, especially for bird, the yearly it was killed 2,000 to 34,000 birds killed by the wind turbine in USA. And if we look at this, the figure on the right side, so that's the if we compare this figure, still any other mortality, the wind energy is way below. If we compare with the conventional energy system, then fossil fuel power plant had more than 14 million bird mortality per year in USA, compared to if we compare with the solar and wind energy system. Then the another is noise. So what happened when wind turbine, the blade is moving, it creates a irritating rhythmical swishing tone that is though less than 1000 hertz, but the continuous this kind of noise is create some annoying, and then it's sometimes it's a bit difficult to tolerate. So that's create this kind of noise. And then the local climate. From the research, it find out that when wind move across the blade of a wind turbine, the existing wind loses significant amount of momentum, which disturb the natural exchange of energy between the land surface and the atmospheric layer, and that may alter the local hydrometeorology. And as well as and some study find out that it increased the temperature. So based on a study in the US, it shows that global temperature could increase 1 centigrade by 2100 if 1% of the energy come from wind energy source. Then the footprint. Generally, wind turbine requires less footprint. For permanently, it's less than 0.4 hectare per megawatt. But and temporary, it requires 1.5 hectare per megawatt because of the construction and the movement and all these activities. It's require more land, as well as it's also create a conflict with the other land use to where to put that on agricultural land or forest land and so on. Then the geothermal energy. The geothermal energy that comes from the ground, power extracted from heat stored in the earth. So if we look at the earth, the different color is indicating the different temperature. And so if you go inner side, that's temperature high, 5000. As you go up, its temperature start to decreasing. So for geothermal energy, temperature is required around 120 centigrade. But if temperature is higher, it provides better energy system, better geothermal and electric production. So if we consider how this system works, then if you look at this figure, that's the cool water going underground and then heat exchange and then come hot stream, and there's a generating the electricity, and again it's go down the circulating. That's the way this energy is producing. The possible environmental impact from the geothermal energy is the compaction, as I already explained to this one, and physical and chemical properties because of the making that big wells to extract the energy from the ground, and soil contamination by mercury or boron, and this kind mercury, boron, as well as air emission, greenhouse and toxic gas emission occurred, but it's this kind of contamination is fully depends on the stream chemical composition, meteorological condition, and resource temperature, and it can vary from location to location. And the water and contamination of aquifer and other water bodies can be contaminated if leakage through the wells, and to establish a well, 2-kilometer well requires 8,000 to 55,000 cubic meter of water. And vegetation and wildlife, as any kind of disturbance, obviously deforestation, habitat and ecosystem loss can occur through this energy system. And another important part is the geophysical and land hazard, that is subsidence. So generally 1 to 55 centimeter per year subsidence can occur through the geothermal energy system. In addition, landslide and hydrometeorological eruption can occur. The footprint, it requires very little amount of footprint, just like a well. So it's 0.02 to 3 hectare per megawatt hour, as well as conflict with other land uses. And the take-home message from solar, wind, and geothermal energy, I'm almost over my time. These energy systems are not free of adverse environmental consequences and have low greenhouse gas emission and land use, and all are abundant in nature. And the major environmental drawbacks are bird mortality for solar and wind, biodiversity and habitat loss for all trees, noise for wind, visual impact, especially wind, hazardous chemicals, solar and geothermal energies. And geothermal energy has a small risk of subsidence, induced seismicity and landslide, which potentially serious consequence can occur if it's happened. And if you are interested to more read about that, the 2 paper we published. And thank you.